This video will show you how to deal with functions that have radicals involved and finding the limits as x goes to infinity or negative infinity. We saw that when we're dealing with the rational functions, those are the ones without radicals, it was pretty easy. You just follow the rules for horizontal asymptotes because that's what a limit at infinity is. But that change, and you also notice that rational functions only had one horizontal asymptote. That changes with these functions that have radicals in them. And it's easy to see if you just take the limit numerically. So if you look at this function, I'm going to take the limit as x goes to negative infinity. I use this very large number to see what happens numerically. And I got 3. So that, by definition, is a horizontal asymptote of that function. But then I tried to take the limit as x goes to positive infinity. And you will see here, I'm going to use a positive large number. And this limit is going to negative 3. So depending on which infinity I went to, we had different values. That indicates that it has 2 horizontal asymptotes that are different on each side. So going to negative infinity, we should be at 3. Going to positive infinity, we should be at negative 2. So what does the graph look like? It's a good way to understand this. I have graphed it for you. So you can see I graphed it in y equals. And you can see that to negative infinity it approaches 3. To positive infinity this way it approaches negative 3. If you want to make that more clear, I'll actually type in the 2 asymptotes. Y equals 3. And then y equals negative 3. That was a minus 1. Y equals negative. You can see those functions look like it clearly approaches the asymptotes. So now that we know these types of functions could have 2 asymptotes, or in other words, approach 2 different numbers as x goes to positive or negative infinity, let's look at a way that we can figure out how you can tell without doing all of this work. So I'm going to use the same function, and I'll show you how you can tell. Treat these just like rational functions. So, and this, I guess the vocabulary I'm going to be using here is not the best for math, but will be understandable. If this were a rational function, which it's not, but if it were, if you thought of it as such, and you were looking at the degrees, well, the degree of the top is clearly 1. The degree of the bottom, you can't really say it has a degree because it's not a polynomial, but the square root of x squared is x. So you can think of the degree, quote unquote, of the bottom being the square root of x squared, which is x to the first. So these degrees match. Therefore, you're going to take, just like we did with rational functions, the ratio of the leading coefficients. But when you're dealing with radical functions, if you're approaching negative infinity, you write the opposite. In other words, the leading coefficient at the top is negative 3. The leading coefficient at the bottom is, now be careful here, the square root of 1. Because that's still in the square root. Now, because you're approaching negative infinity, take the opposite of this number. So instead of negative 3 over square root of 1, it's positive 3 over square root of 1. I should not have this equal sign here because they're not equal yet until we figure this out. The square root of 1 is 1, so we have the square root of 3. So now I can say this limit equals the square root of 3. So for the next one, it's the same function. So we already decided that the degrees, quote unquote, are the same. So we're going to take the ratio of the leading coefficients. It's approaching positive infinity. In this case, don't change a thing. Whatever I wrote down there is the limit. This is the same thing as negative 3 over the square root of 1 is 1. So this is negative 3. So that was the semi-analytical way to do this. The next video, we're just going to do a couple more examples. It's important because the next video, we're going to make sure you understand what the difference is between, like if I ask you what's the limit as x goes to positive or negative infinity, and where are the horizontal asymptotes. So you'll see that in a minute.